So for learning target 11, all that we're doing is we're going to get a set of information and we're writing equations, like we did with ellipses and circles. Just now it's a hyperbola. So just a reminder, we talked about this at the beginning of this week, and then I put it on this note sheet too to make sure you guys know the vocabulary. That way you know what they're talking about and they give you the set of information. So a hyperbola has two axes of symmetry. The line segment connecting the vertices is called the transverse axis and has a length of 2a. Now, the transverse is like the major axis. We don't call it that. It would be like the major axis in an ellipse. So, again, it's from the vertex to the other vertex of the whole axis. So from the vertex to the center, it's just A, right? Does that make sense? Then the other one is called the conjugate axis, and it has a length of 2b units. So yesterday when we made that box, right, remember the box, the rectangle we made? The conjugate axis goes perpendicular to the transverse axis, and it connects the two sides of the box. But so B then the center to a side of that box, if you had a picture. All right, so B is only half of that axis. So two examples first that are relatively simple. Again, just like yesterday, to write an equation, you need the orientation, horizontal or vertical, you need the center, and you need A, and you need B. If you have those four things, you can write the equation. So the first example just says the center is at 1, -4. Well, that's HK. Excellent. A equals 5, and B equals 2. So we know A and B. And it says it has a horizontal transverse axis. So what does that mean it is? Horizontal or vertical? Horizontal. Yeah. Okay, so if we're going to write the equation for number 10, we have x minus 1 squared over 5 squared, which is 25, minus y plus 4 squared over b squared, which is 4, and that equals 1. Everyone know where those numbers came from and why we knew it was horizontal and why we put those numbers where we did? Yes? All right, for number 11 then, the second example. I know, that one was easy. Super easy. On 11, the length of the conjugate axis is 6 units. So what does that tell us? B equals 3, right? The length of the axis is 2b, then b is half of it, so b is 3. The vertices are at 3, 4, and 3, 0. That can tell us a few things. You can find the center. Here's 3, 4, here's 3, 0. So what's the center going to be at? 3, 2, right? Between 3, 0 and 3, 4. Yes. And so we know the center, and we know B, we need to know A. A is the distance from the center to a vertex. So what is A going to be? 2, center of the vertex, 2. So we have B, we have A, we have the center, and if you kind of look at the graph, is it going to be vertical or horizontal? The vertices are what? Vertical or horizontal? Vertical, right? So we have, for our equation, be careful because it's really easy to mess up the center. Y minus 2 squared over 4 minus x minus 3 squared over 9 equals 1. Now, I've had this question a few times today and yesterday, just looking at examples. Never once did I say in hyperbola section that A had to be greater than B. It does not have to. It can also be the same, but A does not have to be greater than or equal to B. So it's not like an ellipse in that way. Okay? Questions about these two examples? I've got two more after this that are a little bit different, but questions about these two? No? All right. Then the next example, we have another definition we need to know. So in the standard form of the equation of a hyperbola, if A equals B, so if they're the same, the graph is called an equilateral hyperbola. So you need to know what that is, so that when they tell you that in this next example, you know what that means. So an equilateral hyperbola just means that A equals B. Yeah, last night, if you had one, you would have had the same denominator, but you wouldn't have had to know the vocabulary word for it. All right, so here's the example. The hyperbola is equilateral. Again, that just means that A equals B. That's going to be helpful in a second. And it has foci at 0, 6, and 0, negative 6. What can I tell from the foci? I can tell where the center is at. That's one thing. So where is the center on this one? 0, 0. What else can I tell from the foci? There's 3 things. There's 2 more. Yeah, I can tell what the orientation is because I know they're on that transverse axis, right? So are 0, 6, and 0, negative 6, are they vertical or horizontal? Vertical. So this is going to be vertical. And what else can I tell from the foci? C. From the center to a focus is C. So if the center is 0, 0, and you know the foci, then you should be able to find C. So what is C? I know C. I'm trying to figure out C. So C would be 6, from the center to a focus. Right? Yeah? Now, this is not tricky. This is just algebra. We know C, and we need to know A and B. I mean, that's all the information I have. Like, there's nothing else, like, hidden in there. I know that C squared equals A squared plus B squared. And this is where the A equals B situation becomes important. If I know that they're the same, well, I only have C. I know 6 squared. So I'm going to change this to A squared plus A squared. They're the same thing. That way I only have one variable I don't know instead of 2. Be 2A squared. So 36 equals 2A squared. And we're just going to do some algebra. Yeah, so we divide by 2. So 18 equals A squared. And for the equation, do I really need to know what A is? No, I just need to know what A squared is. So I'm just going to leave it like that. Because A is going to be the square root of 18. Gross. Yeah, so this is going to go under both y and x because A squared and B squared are both the same thing. We said it was vertical earlier. We said the center was 0, 0. So you have y squared over 18. I'm sorry, my pen's being weird again. Plus x squared. Sorry, it is. I'm focusing on my pen being strange. Minus 18 equals 1. So again, that one's not really difficult. You just had to know at A equals what equilateral meant in this case. Not hard, I promise. Okay, questions about the equilateral example? Okay, then one more. Here's a page. Okay. Like an ellipse, the shape of a hyperbola is determined by its eccentricity, which is again defined as E equals C over A. That has not changed. It's still C over A. Now again, the purpose of the eccentricity is to tell you what the shape is. So if the E is close to 1, that means it's going to be a wider hyperbola. And if it's not close to 1, it's going to be narrower. That doesn't matter to us as much. We just need to know that E equals C over A so we can write these equations. Okay? Hopefully my pen is not going to be strange. That would be nice. Okay, here we go. Last example. Write an equation of the hyperbola that meets each set of conditions. The eccentricity of the hyperbola is 5 over 3. Now, no. We know 5 over 3 is supposed to equal C over A. But we get some other information, so we cannot definitely just say 5 is C and A is 3. That could 5 over 3 could be a reduced fraction. Okay, so we're going to use our other information. Okay? It says the foci are at 10, 0, and negative 10, 0. Right, again, the foci tell us three things. They tell us the center, which in this case is 0, 0. They tell you the orientation, so 10, 0, negative 10, 0 are horizontal, so we know it's horizontal. And what else can we tell from this? We know C. C is the distance from the center to one of the foci, so the C is 10. Okay, so now we go back over to our little equation over here. 5 over 3 has to equal then 10 over A, right? So you can either cross multiply, or you can just look at it and know that it must have been doubled, since 5 times 2 is 10. So A is what? 6. If you cross multiply, you get the same thing, because you get 5A equals 30, and so then 30 divided by 5 is also 6. Okay? So we have A, we have C, we have the center, we know the orientation. What are we missing to write the equation? B. So how do you find B? C squared equals A squared plus B squared. So that's 100 equals 36 plus B squared. So B squared must be 64. It's horizontal, so X is in the front. So we know the center was 0, 0, so we have X squared and Y squared. A was 6, so that has to go underneath the X. 36, and we know B squared is 64, so under the Y squared. It's not that bad. Any questions on this example? Because that is learning tutorial 11 in a nutshell.